I'm going to show you how to make a slide mechanic just using the movement component right out of the box, no plugins, and no custom code. The mechanics are simple. The character just runs into a slide and decelerates over time, unless we're sliding downwards, in which case we pick up speed. The slide contours to the slope in either direction, and we can launch our character at the end of the slide if we're sliding off of an object. The slide ends if we release the button we're holding, or the speed decreases to a certain threshold. This uses the slide animation from Mixamo, cut into 3 parts, transitioning between moving, idle, and sliding. You could just grab those from the description and add to your project if you don't want to set that up yourself. So to set up our slide, I have the running slide animation taken from Mixamo. I've split it into 3 parts, so we're just going to set this up in the anim graph. The first part is just getting to the slide, the second part is a loop, and the third is getting up from the slide. We're going to go and open up our third-person character. And we're going to create a variable called sliding. Then we'll open up our anim class. And in the event graph, we'll need to get that sliding, so we'll cast to our third-person character. And just promote it to a variable. Then we'll put it right after our character get and convert it to a validated get. Get sliding and promote it to a variable. When that's done, we'll go to our main states and open up our locomotion. And from our walk and run idle states, from walk and run, we'll create a new state. We'll call it run to slide. Then from there, we'll make another state called sliding. Then a third state, slide to run. And then one connection to both our walk and run and to idle. For our run to slide, we're going to get the go into slide animation. For sliding, it's the slide loop. And our slide to run will be our up from slide. For this one specifically, if you're taking the Mixamo animation that I put, I find changing the play rate to 1.2 makes it look a bit more natural. And then from our walk to run to our run to slide, we'll get our sliding and connect the pin. And from our run to slide, we could just check the can enter transition. And from our sliding to slide to run, we'll get our sliding and a not bool. And from our slide to run to our walk/run, we're going to get the character's ground speed. And we're going to make sure that if we are going faster than some short distance, we'll say 5. And we want to make sure that this plays for a minimum amount of time. So we'll get relevant anim time on the slide to run. And then we'll say less than or equal to half a second. just so that at least plays a little bit of the animation. Then from our slide to run to idle, we'll take the ground speed, and we'll check to see if it's less than 5. And then finally, on our blend out, we're going to set the duration to 0.75 so it doesn't immediately stand up. And for our slide to run to our walk cycle, we'll change it to 0.5. We may also want to increase the blend time duration to 1 second on our run to slide and sliding. And we'll see how that looks when we set this up and come back if we need to. So I'm going to set this up with a keyboard press. Just on the event that we press Q. We're going to start our slide, and when we release it, we're going to end the slide. So we'll create 2 custom events for that. Say start slide and end slide. We can call end slide when we release. We're going to get a branch after we press our input, because we want to make sure that we're doing this only when we're on the ground. So we're going to get the character movement and check to see if we are falling. And we also don't want to be sliding if we're not moving, so we're also going to check to see if our character's velocity is at a certain point. So we'll get velocity. Get the vector length. And we'll say going greater than 300. Then we can start our slide. So now when we slide, we are going to be crouching. So if that's not already set up in your character, click on the character movement and just type in crouch. We want to select can crouch. We'll also want to check can walk off ledges when crouching. And then if you get analog, I want to change the min analog walk speed to 0, just because we're going to be messing with the inputs a little bit when we are sliding. So first we'll take our character movement, and we're going to get the max walk speed. And we're going to set that to be our character's max walk speed crouched. Then we're going to call crouch. And we'll set a timer by event. We'll promote the handle to a variable, and we're going to call this the surface check timer. We're going to be doing a continuous trace downwards when we are initiating our slide, so then we can see, number one, if we are still attached to the ground, we didn't go off a ramp or fall off an object somewhere. And number two, we're going to contour our character's position to that of the floor beneath the character. So we'll say the timer is 0.01 seconds looping, and we'll get a custom event. This will be our trace to ground. So at the start, we're going to get a branch, and we're going to get our is falling check, and check here. If we are falling and we're no longer sliding anywhere, we're going to call our end slide. Off of our end slide, first thing we're going to do is set our sliding to be false. And we could set sliding to be true anytime after we start our slide. We'll just add it here after the timer. I'm going to get a line trace by a channel. This is going to be at our actor's location. We're going to get two subtract operators here, because this is going to be running when our character is crouched, so our capsule is going to be lowered. And we're also going to be playing an animation that is lowered to the ground, so we can subtract 25 from the Z value of our start, and 75 from the Z value of our end. Then we'll check to see if this trace hits, and we'll break the out hit. We're not going to worry about the alignment with the floor just yet. I'm just going to add a movement input. And the world direction is going to be our actor's forward vector. So when we're sliding, we're constantly moving forward. Now, we want to possibly take away control from the player, so we're going to be going into our move. And off of the forward, backward, add movement input, we'll put a branch. Check to see if we're sliding. We're only going to be using this input if we are not sliding. Oops, I did say this was supposed to be a not bool. So off of our end slide, we're going to clear and invalidate the surface check timer. And we're also going to uncrouch. And we do have a bit of a camera snapping situation going on. If we take our camera boom and drag it as a child to the mesh, now when we do that, it will not shutter. So now we want to make sure that we can go and slide down a slope and have our character match the angle of the slope. So we're going to take the impact normal, and we're going to get slope degree angles. Using the impact normal as our floor normal. But I'm also going to just right click this and collapse it to a node. Let's call the node surface transition just to work in here. Right Y axis is going to be our character's right vector. The up vector is going to be our character's up vector. Then we'll need to make a rotator. And we'll either negate the float here or just multiply it by -1. For our X and Y value, we're going to get our mesh and get the world rotation. And split the structured pin and just use its Z value for the rotator. Then we'll take our mesh again and we'll get the world rotation. And we're going to Reinterp 2 to smooth the transitions from one rotation to the next. And this is going to be our mesh's world rotation. We'll just get an execute pin. Then we'll just get a brake rotator, as we'll need to just take this X and promote it to a variable. We'll just call it X direction. We'll be using this to control the speed of our movement, so then it accumulates when our direction is negative and decelerates when it is positive. And if we go back into our service transition, for the Reinterp time, I like having 0.1 as the delta time, and the interp speed of 1 is also fine. We also want to make sure that the camera boom, its rotation, if it's switched to the mesh, is set to worlds. Otherwise, it's going to shutter again when you transition from one surface to another. And in our anim graph, we're going to go back to the main area, and since this is going to interact with our foot IK for this animation, you can either have not falling or not sliding also set to the control rig. I'm just going to disconnect it for the tutorial. So if we were to test this out, when we slide, we're able to transition up and down slopes. So now that we're done with that portion, we're going to work on acceleration and deceleration. So we'll get a branch right after our movement input. And we're going to get our character movement, and we're going to check our speed for our crouch. So we get the max walk speed crouch. Because this is what we're ultimately going to be changing. We're going to check to see if it's less than 100. And if it is, we'll say that we're going too slow to continue the slide, so we're just going to end the slide. Then we're going to get another branch off of our false. And we're going to make a new variable, and this is going to be our max slide speed. And we'll set that as a float. And we'll check to see if our max walk speed crouched is less than what we set to our max slide speed. For the slide speed, we'll set it to be a value like 1600. That's going to be the absolute limit of what we can slide up to. Then we're going to copy our character movement. And we're going to set the max walk speed, crouched. And we're going to get our current max walk speed crouched. And we're going to add to it. And we're going to get a select float. So we'll check our X direction. For our X direction, it's just going to check to see if we're less than 1. Our X direction is going to be positive if we're going down and negative if we're going up. So for A, we'll say that we're going to add -4, and B, we're going to add 5, just because we'll slow down different rate that we accumulate speed. But this is a very simple check. If you want to have a more robust slide based on angles of measurement, you'd have to expand on this, but we're only going to be worrying about whether or not we're going up or down for the purposes of this tutorial. So I'm going to go back to our third-person map, and we're just going to make a very big slide. Okay, and we'll get a print value so you can see how we are accelerating. And then if we were to go the opposite direction, we slow down. Now we're no longer able to get past that 100, so we change our rotation. Now we need to go and interp our rotation backwards, as funny as it would be to run around like this for a while. I'm going to copy our surface transition node. And off of our event slide, we're going to use this to rotate ourselves back to normal. So we'll set a timer by event. Basically the same information that we had before. And we'll promote the value to a variable, and we'll call it correction timer. Rotation correction timer. And a new custom event. We'll call it correct position. Inside, we don't need to use our floor normal. Instead, we're just going to take our actors up vector, and that's going to be our new normal. Everything else we can keep as the same. And we're going to proceed forward if our actor's world rotation is equal to the made rotator for our target rotation. And we'll give it a little bit of a grace of 1 degree. And connect that to the output. And then we're going to clear and invalidate the timer. which is good because if we go off of the ramp, we're also going to correct it mid-fall. And so when we get to a point where we fall off a ramp, we can also use some logic to propel ourselves forward off of a jump. So we'll get a branch after our uncrouch. We're going to get our character movement. We're going to check to see if we are falling. In addition to falling, we're going to get our player controller. And get is input key down. And we'll just check Q. Then we'll get an AND bool. That'll be the condition for the branch. So that if by the time we end the slide, if we are in the air and we still have the input key down, we're going to launch our character. So with our character rotating, I'd like to just get the mesh and get its right vector, rather than getting the actor's forward vector, though I'm sure in most situations it'll be the same. Then we're going to multiply it and convert this to a float. We'll get our character movement again, and we're going to multiply it by our max walk speed crouch. And we're going to just divide it by 2. That way we have a set direction that we go to, but depending on how fast we're going, we're going to get a bit further of a launch than just having a static launch at the end of our slide, like if we were going off of a ramp. We may also want to do some changes before we get to this character launch. Some other options include setting the gravity scale and the braking deceleration for our falling so that our character can go a bit further. So we got the character movement, and we can just set the gravity scale. Set the gravity scale to 0.8. Set braking deceleration for falling. Maybe 12,000 instead. Then we'll get an event on landed. And we can set our gravity scale and our braking deceleration back to normal. And when this is past the event for the timer, we can set our max speed crouched back to default. Which was 300. And we can still really rotate around pretty quickly. So after we start sliding, we're actually going to set the rotation rate down to 100 for the Z axis. So it's going to heavily cut down on how much we can spin. and then back after we set our crouch speed, we'll set it back to the engine default of 500. So now we have a little bit more control over the character when we try to move. And then at the end of this, I'm just going to make a very poor attempt here at making a ramp. Actually, not terrible. I might want to try to override the Z value on our launch. Could also add a little bit to the Z value. Say 300. Doesn't make too much of a difference if we go off to the side, but when we go off of the big jump. And so that's pretty much all there is to making a slide mechanic in Unreal Engine. And most of the settings that you're going to use revolve around either sliding or gravity or friction in some capacity, but it's all going to be related to the character movement component. No other plugins necessary. So that's how to make a slide mechanic just using the movement component. Further configuration can be done by changing the speed at different values of the X direction. You can also set the launch at the end to only add a Z value if the X direction is negative. And of course, there's still many options to play around with within the component itself, so if you find a configuration that you like, leave a comment and let me know. I want to say thank you to the pillars of the Patreon for their support: Winterberry Shark, Francesco Pota, Kay Panic, and Shay Alexander. And to everyone else who supports what I do in some capacity, and a special shout out to my new student, Bags. If you want to support what I do, or have access to blueprint components ready to drop into your own project, or you want a one-on-one lesson with me, check the description and check out my Patreon. There's also some free stuff there too. But that's all I got for now. So thank you all for watching, and I hope you've been inspired.